In this video, we present Verigraph. Verigraph addresses two key challenges in high-level task planning with large language models, LLMs, efficient scene representation for planning, and plan verification. By encoding scene information into a structured scene graph, Verigraph both enables task planning and automated output verification. Humans can easily understand the spatial layout of the kitchen scene on the left. For example, if asked to move the book from the counter to a bookshelf, they would not have first removed the items resting on the book, the glass cup, and plates. Previous attempts to solve this type of task with LLMs or vision language models, VLMs, have struggled to capture such spatial relationships. Instead, we encode the scene into a scene graph before passing it to an LLM planner. This intermediate representation significantly improves task completion rates. Verigraph is composed of two components, the scene graph generation module, which generates the scene graph, and the iterative planning module, which uses an LLM to generate an accurate high-level task plan. We generate a scene graph by passing an image of the scene to GPT-4v along with a global dictionary, instructing it to use only words from the global dictionary to ensure consistent labeling of objects. For tasks that have language instructions, we generate the goal scene graph by passing the initial scene graph along with the instructions to GPT-4v. We ask it to generate a graph of what the scene would look like if the instructions were followed. This is an example task to demonstrate how Verigraph works. The task is to transform the initial scene to look like the reference scene. Verigraph starts by creating scene graphs for the initial and goal scenes. The LLM planner takes the initial scene graph and the goal scene graph and predicts the first action. The graph simulator verifies that the action is feasible and asks for the next action. The current graph is modified. The planner predicts the next action, but this time the action cannot be executed since the white plate still has a spoon on it. The graph simulator provides the negative feedback, prompting the LLM planner for a different action. This time the LLM outputs the correct action after receiving the feedback. The current graph is modified and the planning continues. The plan is correct since the current and goal scene graphs match. We compare to prior works and show that Verigraph significantly outperforms them. Thank you.